So now I want to talk about set operations. And this is where we can start to really mess with the sets that we've been developing. So 9, 21, and 27 are your suggested exercises. So we're going to look at union, which is a U, intersection, which is an upside down U, complement, which has many different symbols, but I think the book is going to use a little C. And we're going to use difference, which I think the book uses a minus, but I like to use what we call set minus, which is also a backslash. We're going to talk about when sets are disjoint, and we'll talk about Venn diagrams. Okay, so given two sets, A and B, the union of A and B is the set of all elements in either A or B. And this is an inclusive or, so I'm going to add here or both. I guess comma, turn that period into a comma, and is written A union B. Okay? The intersection of A and B is the set of elements in both A and B. Oh yeah, comma, and is written A intersect B. Okay? Now, two sets are called disjoint if their intersection is the empty set. That is to say, if there are no elements in both of them. The complement of a set A is everything in the universe that is not in A, and is written a whole bunch of different ways. I think I'm going to try to stick to A to the C. You also might see A bar, you might see A prime, you might see minus A, you might see tilde A, etc. There's about a million ways. The difference and this should be a C. A set minus B is all elements in A, but not in B. It's also written A just minus B, but I have qualms with that notation because we use A minus B to denote something else that's very specific. But that's how the book does it, so if you write it that way, it's fine. A Venn diagram is a picture that has different regions for all possible intersections of some sets. So the Venn diagrams, and we'll probably do more with this later, but just a quick example, like when you see this, here's A and here's B, you might see this, something like that. So these are Venn diagrams. We'll do more with those later. Let's quickly do some sort of hands-on examples with the basic operations, which are going to be union, intersection, and complement. I might also do a set minus. There's also symmetric difference, which is kind of like an XOR, and that's all the things in either but not both. Also, we should notice difference is not symmetric. Not in general symmetric. So A set minus B might not be B set minus A. There is a way to symmetrize that. It's called symmetric difference, and some people denote it with this symbol, like the XOR symbol, because it's kind of like an XOR. Some people denote it with a triangle. I think some people denote it with a star. We're gonna just kind of avoid that. Okay, so let's do some examples. So let's let A be 1, 2, 3. We're gonna let B be 2, 3, 4, and we're gonna let C be 4, 5. Let's also let the universe be 1, 2, 3, 4, 5. So here I'm being very explicit about the universe. Oftentimes the universe is just sort of understood. It's not maybe made so explicit, but here I want to be really explicit about it. So let's notice some facts. Here are some facts. We've got that A intersect B is going to be, it's the set of elements that are in A and in B, so it's 2, 3. We've got that A complement is C. You also might write this A to the C. I think the book writes it like that. Some other facts. We've got that B set minus A is the element 4. And we notice that A intersect C is equal to this. And if two things have an intersection, which is the empty set, then we call them disjoint. All right, now I want to be really careful about something. So I'm going to do A union B. We notice this is going to be 1, 2, 3, 4. And I want to talk again, I know, surprise, surprise, about the ambiguity of the English language. So we defined intersection as the elements that are in A and in B. So 2 and 3 are the elements that are in both A and B. Now imagine that you were just quickly trying to describe this set in terms of the definitions of A and B. So if you're thinking, then you might say, oh, it's the set of elements that are in A or in B. But it's not unheard of for someone to say in colloquial English, oh, it's everything in A and B. Okay, so some people might communicate union colloquially using the word and. And if you're like, no, that doesn't make any sense, nobody would ever do that, I want you to consider again, you're watching a football game and someone says, who's on the field? Oh, it's all the players from team A and all the players from team B. And we use the word and there. And of course, there it's clear from context. It's all of the players from team A that are on the field. And also, all of the players from team B are on the field. So the and is at a different level. The and is saying statement A and statement B. This and is at a lower logical level where it's all the things that are in A and B. Okay? If that makes sense, great. If it doesn't make sense, great. The point is, be careful with your natural language. It can be ambiguous. Natural language can be ambiguous. Use caution. Actually, I'm going to make this an M dash. Yeah, M dash is a totally underused punctuation. It's like that long dash. There are differences between hyphens, M dashes, and N dashes. N dashes are for ranges. So if somebody says, the meeting will be from 2 to 4, don't use a hyphen. That's not classy. Okay, so this is just a note. Let's now write all these operations using set builder notation. So A union B, so just in general now, A union B is defined to be the set X such that X is in A or X is in B. This is a logical OR. A intersect B is going to be the set of X such that X is in A and X is in B. All right, this is an element of symbol. A complement, so I'm going to write A to the C or A bar. Those are the two most common, I think. I think the book uses A bar. Is X such that X is in the universe, which again has been defined explicitly or implicitly, and X is not in A. And we can do A set minus B is the set of X such that X is in A and X is not in B. All right, so I want to do just a couple of quick examples of Venn diagrams, and then I'll let you escape. So first, let's shade A union B in the following Venn diagram. Oh, and pro tip, don't just make big circles, right? Look at these tiny overlaps. It's difficult to tell whether I'm shading this region or that region. So that's no good. What you want to do is start your next circle right there in the middle, so you've got a big overlap, or somewhere thereabouts. Anyways, suppose this is A, this is B, and this is C. I'd like for you to think about what is A union B. I'm going to sip my tea. Okay, and A union B is going to be anything that's in A, or in B, or in both. Okay, and sometimes we're going to want to draw a big box around this with a U to indicate the universe. Oh, I'll give you some time to look at that. So that's one. Here's another type of question. Let's shade A intersect B union C. Take a second to try to do that one, or just imagine what it would look like. So again, I'm going to start most of the way towards the middle of each region, A, B, C. So A intersect B is going to be this little football shape here. So it's everything that's in here, or here, C, or both. Now let's try describe. So I will shade, I'll draw a Venn diagram, I'll shade some stuff, and then you've got to describe it. So we've got A, B, and C. Let's shade these regions. So almost the same as the last one, except I'm going to leave this region out. This region is unshaded. Take a moment. Sipping some tea here. Okay, so there are a number of possible answers. One possible answer would be A intersect B, which gives us the football shape here. Union, and let's do C set minus B. And that'll give us this sort of fat crescent shape. All right, I'm gonna clean up this union symbol a little bit. It got a little written over. So that's one way to do it. Let's maybe do one more. Let's describe. Let's shade everything in except that little middle triangle. And so this one would be A intersect B intersect C complement. Okay, because it's everything but A intersect B intersect